Hello, today we'll be looking at Lightbox challenge from Sandbox category in Google Share 2023. In this challenge, we can execute a binary payload and custom seccomp plus namespace sandbox. The flag is also written to a system we shared memory segment with the key 0xF7A6. Bypassing seccomp restrictions is enough to read the flag. As IPC namespace is not used, intended solution. Namespaces are set up as the first step for creating the sandbox. Mount namespace is almost empty with just a fresh slash proc instance. After the process is forked again into an init process and a sandbox process, sandbox C process applies a tight second policy, open read write lseek exit, runs our payload init process, iterates over fd is equal to 0 dot dot 4096 and closes them, applies a tight seccomp policy, wait id slash exit, waits for the child sandboxy process. We can notice that there is no other synchronization between sandboxy and init except for the wait id. So our payload might get the run before the init process applies its seccomp policy. If we take over init process before seccomp policy is applied, we get code execution without syscall filtering. Getting RIP control in init is easy, but just overwriting the return address of the close FDs is in slash proc slash one slash mem. We don't really need to guess slash read the stack address at the processes and just forked. So we can calculate it from the stack pointer we have in the payload. Hopefully our payload is also mapped before the fork, so no need of ROP chain. We can jump straight into some part of the payload of the second stage by getting code exec early in a process. We can bypass the com restriction and thus read the flag. Remaining problem is that std out will likely already be closed, so we either have to pull the read flag into sandboxy process by means of slash proc one slash memory. Just recreate std out in a process using pidfd underscore open slash pidfd underscore get fd. Solution in pseudocode. Stage 1. Launch stage 2 in init process before it applies seccomp. Fd is equal to open proc1 memory o underscore rtwr. Stage 2 underscore address equal to at the rate stage 2. Write fd stage 2 address comma rsp return address offset exit. Stage 2 recreate std out pwd is equal to pwd underscore open of 2 comma 0. Std out is equal to pwd underscore get fd of pid of t comma 1 comma 0. shm id is equal to shm get 0x f7a6 comma 128 comma 0. Flag is equal to shmat slash hmid 0 comma 0. Right, std out flag comma 128 exit. That's it. Thanks for listening.